know it's raining outside, or maybe it stopped. That's a good thing. Today we're at the Mobile One seminar. We have Dave and Doug. We have a little engineering and a little sales, and they're going to go ahead and move forward. Welcome.
Thank you. And thank you guys all for coming. I see everyone's getting relaxed and comfortable. Took his shoes off. You need you want a foot rest too? We're getting one for you. Well, thank you very much. My name is David Surasaki. I'm the Global Strategic Alliance Manager for Exxon Mobil. In simple terms, I manage the GM account on a global basis. I only have one account, and I travel basically around the world. I was just telling this gentleman I have 2 million miles on Delta. I'm in the Delta, what they call the 360 Club, which is the top 1% of Delta flyers, mainly because I live in Minneapolis. It's a Delta hub. Fly to Detroit a lot, Delta hub. So any international flights I take are coming out of there. But thank you very much for being here. We're going to go through what I think will be a very interesting list of topics for you that Doug Hakala is going to present. Doug is a graduate from Lakehead University, Thunder Bay, Ontario, Canada. He's been with our company for many, many years, 10 years longer than I've been in the company for 25 years, and he's been with the company longer. But Doug is a member of a number of organizations in the petroleum industry, including the American Petroleum Institute on automotive products and where we launch new products in the industry. So Doug is going to take it from here. I'm going to come back and give you a couple other details about Corvette and Mobile One and different topics that maybe we can address some questions. So take it away, Doug.
Thank you, Dave. As Dave mentions, I've been around for an awful long time. 34 years with the Canadian affiliate of Exxon Mobil. Mechanical engineer by training. I'm currently the passenger vehicle lubricant OEM advisor for Exxon Mobil for the Americas. So I'm on a global team of about 10 people, and our job is to interface with the OEMs, the technical organizations there, the oil groups there, to make sure that we are making products we need today, in 1 year, in 5 years, and in 10 years for them.
Use this when the batteries are low.
Better? A little bit. Okay, sorry. As Dave mentioned, I lived in Canada, in Sarnia, which is about an hour north of Detroit, which makes it very convenient for me to do my job. I spend a lot of time visiting General Motors and Pontiac and the other OEMs as well. Mechanical engineer by training, I was a proud owner of a 1985 C4. When I turned 30, I decided I needed one real bad, and I'm going to turn 60 in a couple years, and I think I'm going to need another one real bad then. So if anybody has a nice two-tone bronze C4 for sale, let me know. I might want to sit in the car again. I also spent 2 years on the Toyota Formula One race team. I traveled to all the Formula One events around the world for 2 racing seasons in 2001 and 2002. I tell people I ran away and joined the circus for a couple of years. It was a wonderful experience. And people asked me what it was like when I came back to Sarnia after 2 years on the Formula One circuit. I said, it's an awful lot like the end of The Wizard of Oz, when Dorothy wakes up in that black and white cabin again. It was a lot like that. Okay, we're going to talk about engine oils primarily. I don't have drivetrain included in this talk, but if you have specific questions about drivetrain oils, we can try and answer those at the end. So, I'm going to start by what is the function of an engine oil, and what goes into an engine oil? You know, what are the components and chemicals that we put into engine oil? What does the term 5W30 mean? What do those numbers actually mean? And we'll spend some time talking about that. Then we'll get into the specific engine hardware. How do you lubricate an engine? That will branch into a discussion about a particular additive that we put into engine oils that contains zinc. I know there's lots of questions, lots of urban legends around zinc and what's important. We're going to talk about oil quality. How do we measure quality? How do you know going to your Walmart that a bottle on the shelf is high quality? Obviously, if it's Mobile One, it is, right? But there are actually designations on the oil bottle that will tell you the quality standards that that product is manufactured to. We talk about Dexos, because that's very important to everybody in this room. And finally, what oil do I use? What oil should I be putting in my new C7 or my C2 I've got under a cover in the garage. So what does an engine oil have to do? Quite a bit, honestly. A properly formulated engine oil is critical to the successful operation of an internal combustion engine, and that's certainly General Motors' goal, and certainly our goal. We want your engine to run well for the entire life of that vehicle. We don't want you to have mechanical problems. We don't want you to have oil-related failures for as long as you own your car. So the oil must have sufficiently high viscosity to separate moving metal components under a wide range of speed, load, and temperature conditions. So that's critical. To lubricate moving metal parts, you have to form an oil film to fully separate those parts. Really the only significant oil property that determines how you generate that film is its viscosity. Too low a viscosity, too light an oil, and you will actually have too thin an oil film to separate the metal parts, and wear will occur. We'll talk about viscosity in some more detail, so I won't get into that next statement just yet. So, also, again, Corvette owners don't worry too much about this, but certainly vehicle owners in Canada do. The oil has to be sufficiently fluid at low temperatures to be pumped to critical engine components on startup. Okay, it doesn't do you any good to start your car and literally wait a minute or two for oil to get pumped into the top of the engine. And a poorly selected oil, that will actually be the case. That is what will happen. It has to protect internal engine components from the aggressive chemical environment inside an engine. Chemical environment. You are burning fuel. That fuel contains a small amount of sulfur. It may contain ethanol. And when you burn those compounds, you can generate some fairly aggressive chemical species that end up in the oil. Okay, you will get some blow by the rings. Those chemicals will end up into the oil, into the bottom end of that engine. So, we have to add chemicals to protect copper alloys and iron alloys. Typically, we're not too concerned about iron. If a steel or iron part is wet with oil, it's not going to corrode. Unfortunately, copper alloys are pretty sensitive to aggressive chemicals. Okay, so we put specific copper corrosion preventatives in our engine oils. If you're running a diesel, again, not big on the Corvette crowd, if you are running a diesel that generates soot, those soot particles need to be kept suspended in the oil. So you do not want those soot particles to stick together, because as soon as they start sticking together, they're going to start plugging oil filters and plugging oil galleries. Soot was never a problem has not been a problem in gasoline engines for the last 30 or 40 years. Certainly an old carbureted car, you could get into the condition where you're running over-rich and generating some soot, but since the advent of port fuel injection, soot hasn't been an issue. Soot is actually making a comeback, though, with GDI engines. Gasoline direct injected engines will generate their own flavor of soot. It's a very different soot from a diesel soot, but it is soot nonetheless. Corvette engines aren't susceptible to soot-induced wear, but some engines are, from a competitive manufacturer. I won't mention any names, but small turbocharged four-cylinder GDI engines are actually experiencing timing chain wear to the point that it's throwing the timing of the engine off. And that is due to soot that is being generated in the oil. At the end of drain, they're actually seeing like 3 or 4% soot, which is pretty high. And it's got to do all of this for 10,000 miles, 15,000 miles, when your ODI or your oil life monitor tells you to change the oil. So what's in an engine oil? We'll start with a quart of Mobil 1 530. to start. Can you give me a page down there? There we go. Between 70 and 80% of an engine oil is comprised of what we call base oil. Okay, base oils can be either mineral-based or synthetically produced. The base oil properties influence the low temperature performance of the oil and the oil's ability to withstand heat. Okay, there are 5 different classes of, I didn't put a slide on this, but there are 5 different classes of base oil as defined by the American Petroleum Institute. Group 1, 2, 3, 4, 5. Groups 1 and 2 are mineral oils, which means actually group 1, 2, and 3, are based on crude oil. They take crude oil, they extract out the lubricant molecules, they clean them up, and it becomes a lubricant base stock. Group 4 oils are polyalpha olefin synthetics. These are base oils that we manufacture from gas, actually, from Decene gas, and produce, long chain, very stable, very high quality, very heat resistant hydrocarbon molecules. And that's one of the components of Mobil 1. So you've got base oil. And I'm going to ask for a page down again up there, thank you. Oh, sorry, group 5 is everything else. Group 5 are, for example, polyoil esters, which are used in aviation jet turbine oils. Okay, you can actually use some silicone lubricants, silicone oils as lubricants. So it's really everything else that isn't in the bottom 4 categories. The next major component of an engine oil is what we call the VI improver or viscosity modifier. It's in it between 8 and 15%. The VI improver allows the low viscosity base oil to flow at low temperature, yet once the oil heats up, it starts thickening the oil. So you take a 0W base oil, you add a viscosity modifier to it, you can make it a 0W20 or a 0W30 or a 0W50. Okay? The quality of viscosity modifiers is really important. Viscosity modifiers are very, very long chain, think of them as rubber molecules that are tightly coiled at low temperatures and start to relax and spread out at high temperatures. If those viscosity modifiers are easily broken, get sheared by engine parts, so you use a very inexpensive, cheap one, your 0W30 will eventually shear down to a 0W25 and a 0W20, and eventually right down to a 0 base oil. So the quality of the VI improver is really, really critical to the quality of the oil you get. And one more page down. Now the complicated part. Okay, on top of these, the 2 major components, we add a variety of chemicals. Between 10 and 15% of the total volume, these typically include an anti-wear additive, which we will talk about in depth in a minute. They will include detergents, and the detergents act to keep surfaces clean. It is to prevent varnish buildup in the cooler parts of your engine and also on the piston. If you have a diesel oil, you will have a dispersant in there, and the function of that dispersant is to keep soot particles from sticking together. You will have an antioxidant, and this is where Mobil 1 really shines, is in the quality of the antioxidant package we've selected. It has a number of different antioxidants in it, and that's to keep the oil from reacting with oxygen. Oil is a hydrocarbon. Mobil 1 is a synthetic hydrocarbon, but it will still react to oxygen. You put it in a dish, you put a propane torch on it, and it'll burn nicely, right? It will react with oxygen. It will also react with oxygen at the temperatures normally found in a sun, 60, 70, 80 degrees C. Over time, oxygen will start reacting with the hydrocarbon molecules and start generating heavier molecules that will thicken the oil. So we put antioxidants in there to prevent that. there are friction modifiers. They tend to be soluble molybdenum compounds, and they are there to reduce the friction in the valve train and in the ring liner interface. There are antifoamants, and we'll talk about why those are important in a minute. There are anti-corrosion, specifically for copper alloys, anti-rust, specifically for iron alloys. There may or may not be a porta present, depending on the base oil. And there will be some diluent oils in those additives, just so that they are mixable. An engine oil is blended together, typically at 60 degrees C or so. You know, it's either an inline blended or it's blended in a big kettle. And so it will be blended at around 60 C and mixed for 3 or 4 hours before it's done. I'm throwing the odd question in here, where Dave's going to select the best answer at the end, and there will be a prize winner. So, I've seen lots of oil additives on the shelves. You go to your Quick Lube, you go to your Walmart, there are shelves of these things. You know, I'm not going to name any names, but they're wonder oils. Put them in your engine, you'll get 10% better fuel economy, you'll get 10% more horsepower, you will get taste great, less filling. Okay? Yeah, yes. Do these make my engine last longer? Who says yes? Who says no? Thank you. Addition of supplemental oil additives can dramatically change the delicate balance of chemistry in the approved oil. Talked about the big long list of chemicals, compounds we put in the oil. Friction modifiers are surface active, which means they find a metal surface and stick to it. Friction modifiers are surface active, detergents are surface active, anti-corrosion, anti-rust, all those additives are surface active. And you really have to balance the amount of each of one of those, or one of them isn't going to get to the surface. So as soon as you put a great slug of anti-wear additive in it, you're going to start affecting other properties. Use of these products can and will void your engine warranty. So any of your owner's manuals will say, please don't put stuff in your oil.
Most of it ends up in your filter anyway.
We spend millions of dollars certifying oils. Okay, if you have a new formulation of oil that you want to get ILSAC GF5 certified, you know, you can count on spending $250,000 to $500,000. And as soon as you put another chemical in that oil, it is not certified anymore. So please don't do that. Okay, what does 5W30 mean? The engine oil viscosities classifications are defined with the SAE J300 specification, and you can buy a copy online if you really want to read one. 2 sets of numbers. The W number, think of winter. Okay? The W number gives you some indication of how well that oil flows at low temperature. Okay, so 0W is currently and will remain to be the best low temperature specification there is. And I'll talk a bit about what some of the limits are. The 30 is the high temperature viscosity, and it is measured at 100 degrees Celsius, which is close to engine operating temperature. So let's look at kinematic viscosity first. So on this graph, this is a viscosity tube. This is a glass tube about a foot tall, and you fill it with oil up to this red line. You draw oil with a vacuum up this tube to this red line, and you put it in an oil bath at 100 degrees Celsius, and you let it equilibrate. It's got to sit in there for probably half an hour before you know the oil in that tube is at 100 degrees C. Then you take the vacuum off the top, and the oil starts to drain down the tube past this red line and then past this red line, and you've got your stopwatch handy, and how quickly it traverses between those two lines is a measure of the viscosity. And we use centistokes at 100 degrees Celsius as the measure of viscosity. So we've got the SAE numbers here. There's a new one. There's one you probably haven't seen yet. you will start seeing 0W16 engine oils on the market in about a year. Yes, wow. Please don't put this in your Corvette. Okay. These are being driven by primarily Toyota and Honda. They are going to be used in their smaller hybrid vehicles to start, but will eventually roll into some of their other products. 16 is only the start. There will be 0W12s coming and 0W8s coming. Okay. 0W16s will be included in the next generation of API specifications, the GF6, which is coming in a couple of years. We are scared to death as an industry that these are going to be on the shelf in Walmart. And unless your vehicle is specifically designed to use a 0W16, you can do some pretty quick and horrendous engine damage to your car, right? So we are working on a communication campaign. It's going to be a challenge. Most people don't know where their owner's manuals are, let alone actually open them and read them. So it's going to be a challenge. So SAE 30s are between 9.3 and 12.5 centistokes. Fairly wide range, actually, these are. 0W40s, 12.5 to 16.3, and SAE 50s, 16.3 to 21.9. Rule of thumb, an SAE 50 is about double the viscosity of an SAE 30. So if oil film is key, why don't we all run SAE 50 oils? It's obvious, right? More viscosity is better. Well, to a point. So as we mentioned, the thickness of an oil film depends on its viscosity. But once the metal components are separated, additional viscosity doesn't help you. It's not going to make them any farther apart. But shearing this high viscosity oil wastes fuel and increases oil temperature, which will reduce oil life. Okay, so oil temperature could be as much as 20 degrees Fahrenheit higher using a 50 weight versus a 30 weight. So using a 1550 versus a 5W30. So the W viscosities, I've simplified this a lot, but just think there are two tests. There is a high shear cold cranking simulator, which simulates how fast your engine will turn over on a cold winter's morning, and a low shear test, which determines whether the oil will actually slump enough to get into the oil pickup. So there's two tests. Without getting into a lot of the numbers, we can say that a 0W oil will crank easily at minus 35 C. And that when the engine starts, it will actually get oil pressure down to minus 40 degrees C. 5W30, again, cranks easily at minus 30, will provide oil at minus 35. But, if you're living, I actually live in a pretty warm part of Canada, but if you live in the northern part, if you live in Edmonton, Alberta, and it's minus 35 degrees one morning when you go out to start your car after sitting there for the weekend, and you have a 15W40 in it, it may start. Cars start very, very well now. You've got direct injection now and high energy ignition. The car may start, but it is not going to get oil. And the oil light will be on for minutes. So that's what they mean. But why are we seeing so many 0W20s now? About I would say a third of the cars being built today are factory filled with 0W20, and that's going to increase. Well, why do we need 0W20s if none of us live in Edmonton, Alberta, except for a very few hardy Albertans? Okay, why do we need 0W20? Well, it turns out that beyond the excellent low temperature performance, there are viscosity benefits during the warm-up period of an engine. So even from 60 degrees Fahrenheit to 100 degrees Fahrenheit or 150 as the engine warms up, the oil is generally at a lower viscosity, so there are fuel economy benefits. So a 0W20 will provide better fuel economy even than a 5W20. And this is the reason for the move to 0W16s. Okay? It is to get the operating viscosity of the oil low, plus the warm-up viscosity low. And interestingly, 0W20s are the factory fill of the Silverado pickups, with the same base engine as your Corvettes since 2014. Bit of behind the scenes on this. All future engine developments for General Motors are being done with 0W20s. So engines that are, so General Motors, I can't speak for Corvette, but certainly the rest of the General Motors fleet will all be 100% on 0W20s in about 5 years.
Anybody still using 10W30s with older vehicles? They're pretty much obsolete today in modern vehicles. Older cars, yes. Yes. Okay.
Yeah. We'll talk about oil selection for some of the older Corvettes right at the end here. So how do you lubricate an engine? 3 unique mechanical systems in an engine, each with different requirements. You've got the valve train, you've got the piston ring and liner, and you've got the main and connecting rod bearings. Okay, different stresses, different speeds, different loads, different lubrication regimes. The front of the engine is fairly easy to lubricate. The drive gear or chain really only requires adequate supply. It's usually a splash or a jet. Typically, it will require an anti-wear to ensure long life. I mentioned that soot is becoming an issue with GDI engines, but not Corvettes. The can bearings, journal bearings like this, are dead easy to lubricate. Okay, if you've got adequate supply and the oil is the right viscosity, these bearings typically last forever. We'll talk a bit about connecting rod bearings, but very easy to lubricate. The oil has to be clean, it has to be there, and it has to be the right viscosity. Cams and followers. Obviously supply is key, so if you've got the wrong oil in the wintertime, the top end of that engine is spinning for 1.5 minutes without oil. That's not a good thing. Detergents, okay, so flat tappet followers though require anti-wear. And that's why there's anti-wear. One of the reasons there are anti-wear additives in engine oil. The oil has to have good detergency to keep the hydraulic adjusters free to move. What's zinc all about? Okay. There are times during startup when the engine when the metal components aren't moving quick enough to generate an oil film. Okay, the oil pump in your car does nothing to generate oil film. It is only there to provide lubricant to moving metal surfaces. It is the actual movement of those surfaces against one another that generates the oil film. Think of a water skier. Water skier is standing in 1 foot of water and he's not moving. His skis are firmly stuck in the sand. As he slowly starts to get dragged, there will be very high wear occurring between his skis and the sand. As he starts to speed up though, he will start generating a water film and eventually lift right off the surface, and his skis will last forever. He has a full film between his moving skis and the sand underneath. When you start your engine, the first crank or two, that's the condition of the water skier dragging along the bottom. And we need additives in there to prevent wear from occurring, and that is zinc dialkyl dithylophosphate, ZDDP. I'm in the US, not ZDDP. Been around forever. Been around for probably 75 years. Okay? It's been in engine oils for at least 60 years. It is commonly used in engine oil. It's also used in hydraulic oils. It's also used in some transmission oils. Zinc and phosphorus come together. They are a single molecule in the oil, and are present in approximately the same amount, same proportion, in an engine oil in amounts ranging from 600 to 1200 ppm, parts per million. Okay? Diesel oils typically are in the 1,000 range. Most of the engine oils on the shelf are Ilsac GF5 engine oils, and they are required to be less than 800 ppm. I know zinc is important to this crowd, so I put this slide together. This is the Mobil 1 product line, zinc and phosphorus levels. So the first is the classic Mobil 1s you buy on the store shelf. And they are at around, zinc is in green, so they're basically 800 ppm.